Yeah. Just here is okay, right?
Yep.
Thanks.
You got pockets?
I got no pocket. Can I just hold it? No choice. You want to start anything, Michael? You want to run through anything because it's your main deck?
Oh,
Yep.
yeah.
Right.
Okay, go ahead.
Right. Welcome everyone to JuniorDev. Go ahead, Xiao. Today. Okay, so we'll be actually starting our speaker to talk at 7:40, and from then actually we'll be starting to do networking. So, who knows JuniorDev? One. Or two? That's all? Three? Yeah. Okay, so basically JuniorDev is actually we came from Australia. So Michael is the one who actually to start the thing, to actually organize a JuniorDev meetup for people who are actually starting their own developer career in the industry. So previously there wasn't much group that is technology agnostic to the point that it actually allows beginners to be part of it. They like to thank Microsoft, Sarah specifically. She actually helped out in terms of the food and also the venue as well to allow us to run our meetup. And besides that, we actually have a live streaming in Zoom through Engineers.SG. So we'll be conducting a Zoom and also a YouTube live stream as well. So if you want, you can actually look at it to comment if you're feeling shy, since it's quite small, but yeah. Good, yeah. So so this is actually a basic housekeeping. So if you want to actually look at the website and also want to join the group, you can actually go to this JuniorDevSG, our Facebook group and our Meetup group. The more common one is actually our Meetup group, but we also have our Facebook group as well, so we can actually post your articles or whatever. Usually our events are run or launched in both. One is actually the Facebook and the other Meetup. So both are okay. If you want to talk to people, Facebook will be better. Alright? Got it? Okay, so our code of conduct is actually very simple. We try to actually make it a safe space for people who are over here, and try to actually leave a gap for people to actually come in actually to talk about it. And also we try to make it easy and try to don't be just be a person. Yeah, just be a person. Don't bother whatever. So try to be a person and just be friendly to it. So everyone is here. Just want to make it safe.
It should be your headline. Be a person.
Yeah, be a person. Yeah. So that's basically our code of conduct. Yeah. So today we have three people who will be speaking. One is actually Sarah. She'll be representing Microsoft. She'll be talking more on developer ethics, evangelist or ethics.
Just ethics, yeah.
Developer ethics. And Christabel will be talking more towards the secure vault from GovTech, open government products. Third one will be Edison, who will be talking about more towards, I think Web3 is more towards the blockchain technology. So yeah, Christabel, Sarah, please.
Okay.
Yeah, thank you.
Feels like I've done too much.
Yeah.
Like, yeah.
Can go to your slides.
Yeah, okay, no worries.
Yep.
Okay, so I feel like I'll do everything. Like, sorry, I book the room, set up the venue, order the food, then like Michael held the presentation, and then also on my computer.
Yeah.
Yeah, Microsoft has more people than me, trust me. But it's just that my team only has myself on developer relations for the region. So, yeah. Okay, so can we just since it's a pretty small crowd, given that it's COVID also, the situation, please feel free to if you want to spread out yourselves. Actually, we did spread out the seats so you can sit one seat away from each other. Social spacing, our ministers have done it. If you want to do it too, feel free. Don't feel awkward. So I'm just going to say it as a baseline so no one feels like, oh, I don't want to offend the person next to me. If you really want to move, just move. It's okay. As you can see, Edison's all the way there. So, okay, and also the other thing is that since it's a pretty small crowd, I was just thinking maybe we can all just say hi and say our names, because I presented to larger crowds before, but if it's a smaller crowd, I find it even more pressure actually. And I don't actually, this is my first junior dev meetup. I know some of you know each other, but I don't know any of you. So if you just want to say hi, can we just go around the room? It will help me a lot. So hi, my name is Sarah. I'm from Microsoft. Michael, do you want to go next?
Hi, I'm Michael from GovTech. Yeah.
I'm Ishu from Carousel.
I'm Max from GoShares.
Hi, I'm Isha from Google.
Abel from SP Group.
Michael from Sciences.
I'm Christina from Athletics.
Hi, I'm Hani. I just graduated from the US.
I'm Gabriel from Police Force.
Ooh, cool.
Hi, I'm DP from Unify.
I'm Xavier. I'm doing a coding camp.
Jem from Core Levels. And I'm Vincent from Achilles.
Okay, cool. Yeah, so nice to meet all of you. Thanks for spending Friday night with us. Today I am, sorry, I'll stay in one spot. Yeah, so tonight actually just when Michael was talking about junior dev, I was thinking like if you're starting out as a developer, these are just some things that I see across the things that I've covered in the developer relations space that I think are really good considerations to think about, and hopefully like when you start building your own solutions, these are things that you can consider as you build them. And of course things will change. I think in the space of the ethics, diversity and inclusion, things change with the evolving conversation, and it evolves really, really quickly. Like you can see sustainability has picked up so quickly in the past 2 years. So anything I say today will probably be irrelevant in the next 6 months. So all I do is just encourage all of you to keep reading up. I'll start off with this slide. So we actually had a community event, virtual conference, last Saturday on March 7th, where we had multiple communities come together. And we actually invited one of our philanthropy leads. Her name is Diana, and she actually talked about how we can use AI for good. So one of her slides that I thought was actually really interesting was around this question, could we see a Hippocratic oath for developers like we have for doctors? So just for context, Hippocratic oath again is to prevent doctors from doing any harm to their patients, especially given that the power that they hold as a doctor for the patient. Similarly, developers, with tech being even more like prevalent everywhere, it's really important on how we're going to use it for good, and some of the considerations like what you can do versus what you should do. So this is just something I'll leave you with. Okay, next slide. So yeah, sorry, my subtitles are killing everything. Okay, it's okay, I'll read through. Basically, the title is like, who am I to be talking about this? I'm actually not just because I'm capo about this whole space, because there's no actually like role in Microsoft that says you're the diversity and inclusion lead or like you're the lead for women at Microsoft. So why do I care so much about it, and who am I to be able to tell you about this? I'm actually just somebody that has just experienced quite a few things. Definitely, each of you have your own experiences, but I'll just share with you some of the things that I went through that have given me some ideas on what this can be about. Definitely it's not the correct answer, but you'll definitely have your own response to that as well. So I'm Sarah Tiam. I'm a senior program manager for developer relations at Microsoft. So I focus around the region at Asia Pacific. In my time at Microsoft, I've done a lot of different things inside and outside of Microsoft that has allowed me to get a better view of just really tip of the iceberg around different communities as well. I have done DigiGirls, which is a coding event to help girls learn how to code. I'm also part of a very diverse and inclusive global team, on the cloud advocacy team, which is why I'm the only one here, but my rest of my team sits in different areas around the world, and we connect a lot remotely. And there's a lot of considerations when you're doing a very globally diverse team as well. I also volunteer outside for underprivileged youth, and there are a lot of things that I've seen there that I actually didn't know about, I didn't think about, around how things are really systemic sometimes, and there are considerations that you never think of, and it's not so easy to say like, oh, if you just work hard, you can make it. There are a lot of considerations as well that people go through, and I think when we develop solutions for that, there's something also to think about. Also part of the Women at Microsoft committee, I actually ran the Mentoring Circles activity previously, so that's where we address a lot of topics that women in tech face. Also am leading the philanthropies charter in terms of employee engagement, so around like how do you get volunteers for different philanthropic activities. So it's pretty interesting, like we do have underrepresented groups reaching out to us saying like, can we use tech to help us to come up with a system that can better manage our databases or better manage the ways that we do a lot of admin processes so that we can actually focus on the main work and the important things here. So that gave me a good idea as well. And also lastly, I am an LGBTQIA+ ally, helping out with Pink Dot. We did try to get Microsoft's venue to help out Pink Dot last year. Yeah, so just that has given me really tip of the iceberg. Does not mean I'm an expert on all these, but having been through some of this has given me kind of an eye-opening experience as to things that we can think about as developers and when you are in tech as an industry. So just a really brief history of computer ethics, because when I was writing this, one of the things that hit me when we always talk about conversations of, I'm sure all of you have heard the term DNI so much, diversity and inclusion, women in tech, equal pay, all these things. sometimes I hear it so much that it feels like some campaigns out there make it just a word, and it doesn't have meaning behind it. And sometimes I feel like it gets a bit lost. And so I question myself, like, what's the history of it? Where did it come from? And so I did a bit of reading up, just to share with you what I have learned via a search engine search. In the 1940s, it really started right there when this person called Norbert Weiner actually wrote a book around, he didn't call it computer ethics, he actually called it a theory around what happens if computers as a systems, because all systems tend towards disorder eventually, so what happens if computing systems become that? So he kind of pioneered the idea that this might exist. And then that was further out by, like, in the 1960s, you heard of Turing experiment where machines can actually have some kind of emotional intelligence. This guy called Weizenbaum actually came out with this computer psychotherapist, and that's when people started to freak out because they started forming like intimate connections with the computer, and they started questioning themselves, like, if computers actually have intelligence, what does that mean for us, and how far should we push it? So that also led to the 1970s around here, where this person called Maynard started the term computer ethics. So she wrote a book around computer ethics itself, and that was followed up in the 1980s by finally a lady who wrote about computer ethics. So this was a brief history of where it came from. And I think from there on, that's where we get to the next part where we recognize more. This is where it really started to blow up in the tech industry. You can see 2007 was still very early on conversations about people starting to call out the fact that sometimes in tech is not very inclusive. It seems like we see the same personas all the time. It was mostly, if you saw from my previous slide, it was mostly white males who are more senior, and so we needed more diversity in the tech industry. 2011, Women Who Code was founded, and I'm sure we all know Women Who Code. We also had like Ellen Powell calling out her VC in Silicon Valley for harassment, which was actually very new at that point in time. Like, a lot of people didn't know about it, they thought she was crazy. She did eventually lose the settlement, but she said it was worth it, and now she's the CEO of, one of the CEOs, I think, of Reddit, so yeah, she's doing really well for herself. There's also things that came up, like, I know the subtitles are blocking, but this one actually talks about being aware of the bias that might come into AI if we don't develop solutions that factor in diversity. So if your AI is based on looking at a lot of white males as your recruitment process, as your main database, then what happens when it channels the next predictive model for like churning out the next potential candidates that you want to hire? So then you have even more white males, and then we will not get diversity in that space. And then also today we see all these communities popping up, not so much organizations, but it's really taken a global phenomenon for different communities to pop up. So if you look behind me, you'll see Backstage Capital covering underrepresented groups, Trans Tech Social covering the non-binary or trans community, Tech Ladies, Women Who Code, that's right here in Singapore, and also just bring out Female Geek in Indonesia, and also LGBT in tech in Auckland. So these are just some examples. Of course, I just want to show how it goes across the spectrum. It's not just race, it's not just gender, there's actually a lot more. Okay, so I'll talk about really three main areas really briefly, just to give you a taste and just to give you a sense of what I've learned through on my experience, and then feel free to then learn more on your own. So I'll talk about diversity and inclusion first. I'm sure all of you recognize these terms, right? Women in tech, people of color, accessibility in tech, LGBTQIA+. Anyone knows any other diversity terms that they've heard, or that is not listed here? Anyone from the room? No? Yeah, okay, well, there's a lot more than this actually. So initially when I first started out in this space thing, like, okay, I started raising my hand for things at Microsoft, like, okay, I want to try like doing women in tech stuff, I want to try to be more diverse and inclusive. I was like, oh, it's quite simple, right? There's only like 4 categories, there's not so many things. But then suddenly when I started researching, I was like, oh my god, there's a lot. So, there are a lot more things to address. There's equal pay, ethnic minorities, non-binary. For the case of Singapore, SES is also an issue. Rural communities, working mothers, working fathers, there's a lot more than we think. This list is not exhaustive, there's a lot more than that, but the point of this is that it's not a finite goal, there's never a finite goal, there will always be new categories popping up. The idea is just to really keep an open mind and also keep an open conversation. You never know what the next community or the next group that we need to think about, and we might not even realize that, but they might feel unincluded in the conversation. So I think in tech itself, how are you always able to encourage that open conversation is a really important point.
Question.
Yeah.
What's neurodiversity?
Oh, neurodiversity is like, the way that the brain functions. So the idea is that there are many different ways that it will, like personality or the way your brain thinks, the mental state that you're in, there's a whole different range as well. So that goes to another level, like you won't even realize it, right? Because they might look a certain way, but then how they process information might be different. So that's around neurodiversity. Yeah, I might be misrepresenting that, but please read out the proper definition, but that's generally the idea. Yes. Yes.
To that, it sort of, to give you one example, for example, people who are on the spectrum when it comes to autism, generally do not have full-time stable jobs because people just assume that they can't focus as much, they can't contribute as much. So one of the things that neurodiversity falls under is things like
Yeah.
on the spectrum, for example.
Thank you. Yes, that's a really good one. So this is on diversity and inclusion. Next one, accessibility in tech. There's a difference. So there's accessible tech and there's also assistive tech. So accessibility in tech, you might hear the term often, but it doesn't just refer to people with disabilities. It refers to just making tech accessible for everyone. So think about things like, especially in a global team, I also realized that language familiarity is a thing. So my Korean teammates, I need to speak like maybe 1/10 of the speed that I'm speaking at, just so that they understand what I'm saying. And it goes both ways, right? So they also sometimes, when they communicate back, they also have to check the way that they speak, or is there any way that they can add subtitles that make it easier for all of us to understand? So that's around accessible tech, and of course, assistive tech is around making technology that is more, that is easier to use for people with disabilities. So, just simple things like knowing the difference. Each of these categories, there's a very different nature to each of them. I would say don't go into each one thinking that, oh, okay, I need to define all the categories immediately. I need to, the nature of it is always very different per category. So I think always reading up a little bit about that. So this is really just to start you off. I did want to share this chart. I thought it was quite interesting around accessibility in tech. This is a way to think about it. It's not the only way. But that you can think about it in terms of, it's blocking, but the subtitles are blocking. But there's permanent, temporary, and situational states of the way that people are in. And there's also, you can also go by the way the senses go. So touch, see, hear, and speak. So these are the
There's a way to turn the subtitling differently.
Oh.
Let me try, huh?
Yep.
Subtitling settings and above slide, below slide.
Below, you try below, I guess.
Try that.
Hello, test. Okay, yeah.
Never mind.
Okay, it is not accessible to anyone because you're blocking everything. But but you get my point. This is some ways that you can think about it as well for when you're planning your events or you're planning your meetups or your hands-on labs. How do you consider all these factors? Okay, and I'll just give some examples. So like what I spoke about earlier on, like people, assistive tech, people with disabilities. I think Google Maps is exploring, I don't know if it's available yet in Singapore, I didn't actually see it. But they're exploring routes where you can actually take like accessible routes and you can choose that. I don't know, Googler, you might know, is it available yet?
I honestly don't know.
Okay, yeah, maybe in the U. Is it? Oh yeah, I don't know, I haven't seen it in any of the travel apps yet, but I know that this was talked about. This was an example of us turning on live captions. So we try to caption everything that we have. My Korean teammate actually was the one that said like, it's great that I can now read and understand your event better. Then this last example over here is that, thinking about accessibility also in rural communities, like especially with the coronavirus happening right now, internet broadband might not be available in more rural areas. So it must be a lot harder for them to attend virtual conference, or they can't even attend it at all. And that really affects the way of life. So how do you create solutions to solve these kind of issues? Okay, sustainability. I don't need to tell you how bad our world is at right now. I just need to show you a photo of like, if you can see Greta Thunberg and David Attenborough having a conversation, you know something is up. So just don't need any context there. But I did want to talk a little bit about sustainability. These are just 3 ways that I see, well, so far the people that I've seen or the developers I've seen are embracing green. I think the green initiative is something still quite new in terms of solutions that we can come up with. So the problem isn't new because everyone talks about it nowadays, but the solution is still being formed. Just 3 simple steps that I could propose is that firstly, aligning with green priorities. So as a developer coming up, how do you find organizations that have green priorities in mind? How do you find projects that have green priorities in mind? Secondly, environmentally responsible developer. So you can also, like, I've shared some examples over here of like communities that you can search up and join on your own. Like, they are active Slack groups talking about how they can be more environmentally friendly when they're developing their solutions. You know, how do you develop apps that consume less electricity, for example? How do you have best practices around not always traveling down for conferences? Because that actually consumes a ton of carbon. Can you do more virtual conferences even when it's not coronavirus time? Right, so these are things that you can check out. I also saw this, I thought it was quite cool. I saw this yesterday. It's about a search engine that is like a search engine that Google has now added to their Chrome features. But every search that you do helps to send some money to help to plant a new tree. So it's pretty cool. I don't think it's as robust as Google, but yeah, they are eco-friendly, so you can check that out. Okay. Yeah, I just want to share some examples of solutions that work for sustainability. So if you're thinking about, you know, another thing besides being responsible is also, can you go above and beyond to come up with solutions that solve climate change issues? So just 2 examples of Microsoft AI for Good program. We do sponsor and support AI for Good solutions, especially when they tackle climate change. So these are 2 examples that came out. One is TerraFuse, which actually looks at how to predict forest fires that are happening. So this is very relevant given the whole Australia situation that's happening. Another one is iNaturalist. So given conservation issues, how do you create consumer, like user-generated information where people can just use a smartphone and take, and also help to identify the different species, and using the cloud can actually create a repository of conservation species so that we can all be more aware. So these are some examples you can think about. Last pillar, trust. So last of all, I think being ethical as well. So these are around things that we can and then should or should not do. So around trust, just 2 resources that you can actually look at for Singapore's case. GDPR, I'm sure all of you have heard of GDPR. Anyone not heard of GDPR? Yeah, totally relevant. Again, very globalized world now, so you never know if you have a European citizen in your audience. Best thing to do, especially if you're going to collect private data through your app when they log in or register. How do you make sure that you adhere to these standards? And how do you make sure that everyone's very aware that they're opting in? So these are things that, like, even in Microsoft, like, whenever I do an activity, it's actually a lot of work because we have to make sure that we comply by legal standards and compliance standards. So this is something that you would want to consider when building your solution. Okay, last one. So just simple ways around how you can also be an ethical developer, which is just according to me and not according to anyone else. So yeah, just take it as a reference point. Firstly, I think stay woke, which just means that read up on all these things that are happening. As I mentioned at the start, they can always change every month or every 2 months. So always read out in the news on what's happening so you get a gist of what the conversation is now about. Secondly, listen into multiple perspectives. So don't just take one source as the main truth. Don't even think my source is the main truth. Listen to a few perspectives and form your own. Again, like on this space in ethics, I think it's very personal. So take some time to form your own opinion. I think that's the best way. Thirdly, encourage open conversation. So any conversation they are in, I think keeping an open mind, open space for people to feel safe enough to share their views, that is in itself inclusive. So that's important. And then fourthly, look for positive and negative examples. So in all the examples that I mentioned earlier on, there are examples that are negative where things have gone pretty bad, right? Like Cambridge Analytica, where privacy was actually infringed on. But there are also really positive examples around how people are going the extra mile, like the Ecosia search engine one. So look for good examples so that you can kind of model after it and have a better idea there. And lastly, be an advocate yourself. So just like myself, sometimes it's not a formal role in your organization, but if you can build that into everything that you do, that will actually change the way that a lot of things are being built. So yeah, that's all. Thank you. Oh, any questions? No? Okay, all good. Thank you.
Thank you. And next up we have
Is it changing laptop?
Yeah.
You need it from here on the live stream. Yeah, okay, put on.
just hold it? Do I have to hold
No,
it?
no, no, no.
Oh.
Put it on just now. Yeah. Probably your, yeah.
Yeah?
Yeah, just put it to.
Sorry. Yeah, okay, hi. So I'm Christabel. I'm a software engineer at Open Government Products. And today, so OGP, yeah, we are a unit inside GovTech Singapore, and basically we build tech to solve public good problems. So today I'm going to share a project that I've been working on, and it's called Vault. And in particular, I'm going to talk about how I implemented authorization with an open source library called Casbin. So before I go into the meat, sorry, having a bit of a... So before I go into the meat of the technical details, I'll just give you a brief introduction on like why we decided to build Vault and what exactly Vault is. So when you talk to public officers, I think one of the things that you'll hear from them that is a big frustration for them is that sharing data within the government is hard. So why is it hard? It's because the current process as it stands is that they have to go and find some common contact or cold email someone to find out who has what data and whether it's appropriate for them. And then they have to email for approval, right? So firstly, that first step, what's the problem with that? Is discoverability. Because there is no standardized data dictionary that is digitized, they don't know what exactly is available, what is in the universe of government data, and who exactly to approach to find it. So if they do manage to find out who has the data and go and approach them, then they have to write emails to get approval from their superiors, which will then have to go on to the superiors of the other agency. And there's this like back and forth email chain. So that's the request process. It requires usually bilateral or multilateral agreements and different kinds of forms and processes as well. There's absolutely no standardization. Some of it is paper, some of it is digital. Basically, the requester does not know what information exactly they have to provide. So if they do manage to get the approval, they can now try and get the data. So in the data transfer part, there's a long lead time. Why? Because they have to get it over an encrypted thumb drive. So someone has to put it in the thumb drive from some kind of database. A lot of them are legacy databases. And then physically pass the encrypted thumb drive to the requester. So it involves someone, I don't know, driving, cycling down, whatever. And I think that with modern day kind of systems, you're used to getting data programmatically, right, through APIs. But obviously with this encrypted thumb drive, that's just not possible. And finally, the last one is accountability. So because of all these different processes, you need to trust that the person getting the data, that their agency has processes in place to ensure that there's no data leak, and that if there is a data leak, then they have the process to find out who exactly is accountable for this data leak. So in order to solve these four main issues, we decided that we should design a shared central repository and accompanying service that will help government officers discover and access the confidential data securely. So from my description so far, you can see that basically the system has two core aspects, your data sets and the ability to request for these data sets. And that's what I'll focus on in this talk as well. So just some visuals for you. This is Vault as it currently stands. So this is what a government officer will see when they log in. The first picture is the homepage. And you can see that there is a card view of the latest data sets that are uploaded by an agency. There's also a list view, and then there's a search functionality. So you can type in whatever keyword you want. It searches the data sets on their title and description. And we might also want to extend it to include like the different columns that are in the data sets. So when you do find the data set you want, you click into it. At the bottom, you can see this picture over here. It's a data dictionary. So it's within the individual data set page. And so this tackles the discoverability issue. You can see that we've listed out all the columns, the title, the description. So what exactly do these values represent? And also the raw or derived category. So that's useful, especially for, like, example, data analysts. They need to know whether it's an aggregate data or is it the raw granular data. And so this really helps people to be able to be like, okay, is this data set relevant for me? If not, they just request it, and then they don't know, like, whether it's actually going to suit their needs. So if the user decides that they do want to request a data set, they can go into the data request form and add the data set. So because what we envision is that officers are going to request it on a per project or like per assignment basis. So they're going to need to add multiple data sets, so we support that functionality as well. And then they just provide some like justification as text fields. Right, so after the request has been submitted, the approval will go off to the relevant parties. So one of them would be the requester's own superior within their agency, and also approval will be sent to each of the dataset owning agencies. So because we are allowing requesters to request for multiple datasets, we need to send the approval to each agency that owns any of these datasets, because all of them have to approve the request for it to go through, basically. Yeah, so this is what the approvals will see. And finally, if it has been approved, the request, then the user can get it on demand, right? So they can just go into the system, download it whenever they want. And if, let's say, they delete or accidentally modify the dataset once they've brought it out of the system, they can always log back in and get it. They don't have to go through this whole process again. Right, we also obviously do expire the request so the person cannot access it like indefinitely. So from what I've described so far, you can see that there is a need to have some kind of permission set to govern who can do what. Because even if I'm a legitimate government officer, you don't want me running amok in this system and accessing the activity of like all your government officers and all the data sets. So we do that through a combination of authentication and authorization. So authentication is concerned with like whether I am a legitimate user. So for example, who am I? I'm Christabel at open.gov.sg when I log in, and so I can access it because I'm a legitimate government officer. But even though I am allowed to go into the system, I can only do a few things, right? So for example, I can read the dataset description, which is that dataset page where I can see the dictionary and the preview, sample set preview. I can also read my own requests that I've made, and I can create my own requests. But because I'm not an admin user, I cannot create my own dataset, so I cannot write to dataset. I cannot approve other people's requests, and I obviously also cannot read other people's requests. So authorization is really to do with restricting a user's like actions to their assigned scope. Right, so how can we implement authorization? One way is through the most like basic implementation is an access control list. So what an access control list is just a giant set of rules. It's a list of permissions that you attach to all the objects or resources inside your system. So you will specify which user is granted access to which object and which action they can perform. So within Vault, we only have read and write, but obviously you can further differentiate it to include like delete as well. And so each entry will have a subject, you will have a resource, and you have the action associated. So for example, this little green man, if he can write to this for approvals, he will have the permissions for those for approvals. And this little man below, if he can read these four data sets, he will have the permissions for that. Right, so what happens with an access control list is that it just gets exponentially large the more users and resources you have. So I just have like 8 users and 8 resources here, but it looks like a complete mess already. And it just grows and grows because you need to specify every single combination of user, resource, and action that is possible in the system. So what's an alternative to this? So there's also another model called role-based access control, and it's basically where you just group your users into the different type of roles that you have in the system, right? And the good thing is that you can give your users different roles, and they inherit the permissions from all those different roles. So for example, here I have a group A and a group B, type A and type B, and 4 users in each group. And I just place them inside that group, and I associate that role A and row B with these permissions, and then all my users will inherit those specific permissions. Right, so inheritance is what supports the role-based model of access control. And another nice thing is that you can compose more widely encompassing rows from your more granular rows. So for example, if I want like some kind of super admin that can do what A and B do, then I just put like C equals A and B, and then it inherits all those permissions. So what else can we do? I found that RBAC alone wasn't enough. For example, if I have an admin user and I want them to be able to see the approvers from their organization, if I just have an admin type user and then I try and give it access to the approvals, they would be able to see the approvals from every single organization, and that's not really how it works. So this is quite similar to, I guess, how like AWS has your environments and you can only see yours, right? You cannot see those of other users. So you have domains. So here you have your organizational domains. And if I want to add a particular resource, I only want to let Alice and Bob see these resources. Then I just add the permissions within organization A and for the type of user A. So the nice thing is that I can put my resources into different domains. I can share them across organization A and B, or just isolate them to within organization A. Okay, another little extension that I did was to group my resources. The same way I group my users, I group my resources into the different types. And again, that simplifies. So you see, from that whole giant mess of arrows I had earlier, now I just have very clean 3 arrows per domain. So just to do a quick comparison, with an ACL, with 10 users, 10 resources, I have more than 100 rules, right? 100 rules is assuming that each user can only have 1 permission for 1 resource. Anything more than that, it just is even more than 100. And with RBAC, with your domains and resource groups, the same configuration, I only need around 24 rules. And so I'll explain why it's only 24 rules. Right. So I have 4 rules that assign the domain groups and the roles. So if you can see, lines 1, 2, 4, and 5, those are my policy definitions, right? So I have my role, which is of type A. Inside the domain organization A, the first 2 are for domain organization A, and it's to read and write the approvals, the resource group of approvals within organization A. And lines 4 and 5 is the same kind of role A, but it's for read and write within organization B. So that's 4 rules for that. 10 rules for assigning the users to 1 role. Obviously, that's assuming that your user can have only 1 role. But lines 7 to 10 show 4 examples of how I do it. So I say that Alice belongs to domain organization A and she has role A. And then Ellen has the role A inside the domain of organization B. And finally, I have 10 rules to assign your resources to groups. So similarly, your approval 1 belongs to approvals of organization A. Right, so RBAC that's implemented with the open source library Casbin, what's good about it is that it's extensible and flexible. So I can assign multiple roles to my user and I can assign resources to multiple domains. So for example, Alice used to belong to only organization A. If now I want to give her the type of role A inside organization B, all I have to do is to add 1 line, right? So on line 8, the highlighted one, you see that Alice now has the role A inside domain organization B, and she inherits all the relevant permissions. So I don't have to say like, oh, she needs to be able to access these 1,000 like data sets, these 2,000 requests or whatever. It's very simple. All right, so I'm just gonna give like a little bit of detail on how exactly you can use Casbin. So the thing that I showed before, the code that I showed before was your set of rules. So that's basically inside some kind of database. And this is the configuration that will help Casbin decide based on those rules, how can it check whether someone is allowed to perform an action. Right, so the first 3 things that I have over here are my bindings. So these are all definitions. The label R is a request definition, the label P is a policy definition, and then the G's, they are role definitions. Okay, so basically the definitions give me bindings. For example, if you send a request to my API endpoint that's like post to /datasets/the dataset ID, what the middleware will do is to transform that request into an R. So the R label, the request definition. So in that case, if let's say I'm the one making the request, right? My subject, the first field, would be my email, so christabel@open.gov. The domain would be my organization, so OGP. The object would be the dataset ID that I get from the endpoint. And then the action would be based on the HTTP request method. So a post is equal to a write. So So that's the transformation that the middleware I wrote will handle. Yep. So similarly, your policy definition and role definition are just bindings as well. Okay, so going on to the policy effect. The policy effect basically defines whether that request should be approved or not. So you notice that there's this p.eft that's underlined over there. Basically, EFT stands for effect, and in this case, it's allow, because if in your policy definition you don't specify an effect, the default is to allow. So the other option is to deny, but for that one, you have to explicitly specify it. I won't go into that in detail for now, but allowing the deny basically means that you could do something that is conditional, right? So you can say that the policy effect will be if there's a policy that allows this request and no other policy that denies this request, then allow the action to go through. So it can get very complex, your policy effect, but in this case, I've kept it simple because that's all the system requires. Okay, so the next biggest part will be the matcher. Basically, what has been is basically just like a pattern matcher. It's like a pattern matching game. So, for example, if a request comes in saying that admin@data.gov.sg, who belongs to the domain open government products, wants to read the approval with the ID 123, I call the enforcer method of the Casbin API, and it will, based on the matcher, try and match against the policies in the database. Okay, so I'll just show you briefly how this process goes. And right, so based on the first clause that you see up there, it says g r.subject p.subject r.domain. So it will go inside the database and try and see whether there is such a policy. So the request subject you can see is admin@data.gov, and the request domain is domain_OGP. So if you look inside the database, you can see that on line 3, there is such a policy, right? And from that policy, you can see that the second field, policy.subject, that's going to be role reader OGP. Sorry, this is on line 4, right? So going on to the second clause of the matcher, it says that request.domain must be equal to policy.domain. So what's the request.domain? That's going to be the second field. So domain_OGP, that's my request domain. Inside the database, there is a policy that's on line 1. The policy says that my second field is also domain_OGP. So the request domain does match the policy domain, right? So going on to the third clause, it says that there should be a G2 role definition with the request.object and the policy.object. So you see that the request.object is approval with the ID 123. And again, in the database policy, you see that the policy.object is approvals_OGP. Right, so if you see on line 6, there is such a role definition, right? There is a definition that says that G2 should be for approvals_123 and approvals_OGP. So you can see that it goes across all these rules and tries and match it based on the inheritance. So it's not immediately obvious. It's kind of like a chain pattern matching game, but that's basically how Casbin tries to match the different rules to see whether an action can be performed. Okay, so one last thing that was interesting for me is that for our system, we couldn't just use organizations as domains. And why? It's because when you make a request, it actually belongs to the individual and not the organization, right? So if, let's say I'm in OGP and I create a request, I don't want to just attach the permission to OGP, meaning that like all my fellow OGP team members can see my request as well. But I cannot just keep the request as a single resource item, because I need to associate the approvals for that particular request, and I also need to add the permissions for the relevant admins to view this request. So what I eventually came up with is that actually requests function as their own little domains as well. So by making it a domain, it pretty much functions the way as organization domains do. I create a reader role for my request domain. I associate it with a read permission. I create a writer role. I associate it with a write permission for the particular request. And finally, I also add a resource group, which are the approvals for this request, and I give it a read permission. So being the creator of the request, I then have the following role definitions. So Cristobal@open.gov can be a reader for this domain and can also be a writer for this domain. That means that I can read and write to my own requests, and also based on the line 3 permission, I can read all the approvals that are associated with my request, because I need to find out the status of the approvals that are associated with my request. So what happens when an approval needs to be created? So previously in this example, you can see that there is a role definition that says that approval 123 belongs to the organization OGP, right? And this policy ensures that your OGP admins can go and read and modify the approval. But for the requester, who is maybe from a different organization, they also need to be able to read these approvals. And that's why there's this extra role definition here that puts 123, the approval 123, inside the domain of request 123. And so that means that as the requester, I can now, based on this policy in line 3 over here, I will be able to read all the approvals that are associated with my request. Right, so in order for the admin users to be able to read the request, right? So if I am an admin user and a request has come to me and I need to approve it, I need to have the permission to see that request, right? But because it's in its own domain, so I need to inherit the correct permissions. So I say that all the admins of OGP can be readers of that particular request inside that request domain. Yeah, so this was something that I didn't see was a pattern that was used before in other implementations of Casbin. So it's just something that I realized needed to be done because of the particularities of our system. So I think that this embodies very well how OGP works. We use a lot of open source code, obviously verify that they're well maintained and used by other people so that bugs will be found and stuff like that. But I don't think that it would have been really very possible for me to implement authorization the way I did if there wasn't already this kind of pattern matching library to help me do all of this. So it would have been a lot more difficult. And I mean, a lot of open source stuff out there is really good. For example, for Casbin, they've created support for not just Node, but also Go, PHP, Python, .NET. And yeah, a lot of other companies like Cisco and stuff use it as well. So I thought that this was a good example of how we use open source code in our development. Yeah, thank you. If you have any questions about this or work that OGP does, feel free to ask.
Cristobal will still be around for a while. We can always chit-chat with her later. And last we have Edison. Cool. For the recording. Stick on your shirt.
Do you hear a sound? Should be fine?
Yeah, that's fine.
Okay. Okay, here we go. Hi, hello everyone. So thanks for spending the Friday evening listening to how to build a Web3. So my name is Edison from Achilles, and Achilles is a marketing technology company based in Singapore. We build software solutions to make marketing more efficient and transparent. And the reason why I'm giving this talk is because as part of the technology stack that we use, blockchain is actually a very important portion of it. And I'm in this blockchain space for the past 3 years, starting out all the way from grad school, where I was researching on blockchain, and my first job in Zilliqa, which is a public blockchain based in Singapore. So I'm here to share with you what I've learned about this amazing technology and what it takes to build an application on that. So the agenda that I'm going to cover today is very briefly what is a blockchain from a software engineer's perspective, and also getting started with some tips about how you can build your applications on a blockchain like Ethereum. So starting from a very high level question is that I think many of you already know how to build a simple application. It can be as simple as a web application, and you know how to make certain requests and response. But how is it good? So how is blockchain different? So let's go back to the fundamentals. I'm a little bit of purist. So to me, blockchain, the definition of blockchain is this, and it is from the blockchain. It's from the Bitcoin white paper. Because after being in this space a while, you start to see that many people claim that they have a blockchain, but they don't really have this concept of blocks and chain. So it's kind of like strange. So we start off with this problem of like transactions. So transactions, in a very briefly, is that let's say I want to send you a Bitcoin. What happens is that I use my private key to sign a transaction, and we get a signature. And if someone else wants to pass on that Bitcoin to someone else, then you will sign on the hash itself. And along the way, we can always verify based on the chain of signatures and trace it to verify whether if someone has a blockchain or not, has a Bitcoin or not. And so after all of this is done, because there's a transaction kind of like sequences, so we go on to the blocks. And on every block on the Bitcoin network, which usually one block every few minutes, you get a block with multiple transactions inside. And at a high level, there's a previous hash of the previous block, and the nonce of the new block. And it will go on and go on and go on forever, and it is an infinite state machine. So fast forward 6 years later, so Bitcoin came in 2009, and in 2015 there is Ethereum. We started to get introduced to this concept called smart contracts, which is I think where most of the exciting things come from. Smart contracts are basically pieces of computer code on the blockchain that automatically executes itself. So if someone wants to say that, all right, if only this condition is met, then I authorize the payment. So contracts and users can send transactions to each other. So contracts, like smart contract, can call another smart contract, and users can also call a smart contract to evoke certain functions. So we go on to move into what is like Ethereum, which is like an infinite state machine. So let's begin with the first state. So let's say everyone has like $100 in the ledger, and we make a transaction called like at least transfer $50 to Bob. So on the new state, the state will be changed, and this goes on forever. And all this transaction and this verification is agreed by a global network of nodes that are operated by miners, and this is modified over time by transactions. So in a more technical and more theoretical way, and this is it. What we call is an infinite state machine is because whenever you have transactions in, the state changes, and the state changes, and it changes over time. So it is a very it is one of the concepts of like computer science of like state machines. There are infinite state machines and there are discrete state machines. Why am I saying this is because it's very important for the subsequent thinking around how you reason about smart contracts. So I think where the exciting things for software engineers is that blockchain and smart contract programming is interesting in this few ways. One, smart contract is complex. So a piece of code, which is like maybe say 20 or which could be as little as like say 30 lines all the way to 300 lines, it's quite rare to even see a smart contract that is like 1,000 lines. And this smart contract has to do a lot of things. It must be able to store data, it must be able to declare functions, and it must be able to do manipulations and arithmetic like addition, subtraction, multiplication, etc. So this 1,000 lines of code, which is going to be very little compared to what many of us are used to in our daily work, is that it contains a bunch of logic, and it can get quite complex over time. So being able to think about this in a time frame of like, I need to do so many things in this 1,000 line. How do I do it in the most effective way? Is one of the challenges here. And also, I think the second thing is that because when a smart contract is being deployed, it is like a honeypot on the Ethereum. There's just so much money there, and if you are not careful with how you program it, then that's where money can be lost. Because on the Ethereum blockchain, it could store like cryptocurrency, and this represents money. So this is actually something that the developers have to be cautious about. The scary thing is that as developer, we only know how to prevent ourselves from bugs when we can foresee this. Like for example, I can only write test cases that I think that this will go wrong. but we do not know exactly what will. So we may think that we know what is going to go wrong, but we also do not know actually what might go wrong. So what it means is that you might, because if the developer miss out on some test cases, that's where things break. And on the blockchain or smart contract, this could be disastrous. So so in 3 lines, what makes development on blockchain different is that smart contracts are very complex, and it must be able to store states and able to communicate with other smart contracts. So and also transactions are not free because the computations needs to be calculated ahead of time. So you need to know how much gas or how much credits you think of gas as a credit that you want to allocate the sufficient amount so that you can call it. And blockchain is immutable. So once you push a new code out there, you cannot update it as simple as like say, oh, patch the version. So you need to be very careful of what happens when you push a code to the blockchain network, because if there's a bug, it's very hard to fix it. So yeah, so those are the few things here that I think is very interesting about blockchain. And also, I mean, from the perspective of application developer, I mean, I came from the background that I do both. Like we have applications and we have a blockchain component. So sometimes I have to learn how to change between 2 mindsets. All right, so starting with very practical things about how do you get started with blockchain smart contract programming. The one on the left side is where we are most familiar with. So you have a web dashboard, you point to a server, you point to a database, and this is what most software is. But on the blockchain network, right, you could connect directly to this like network of nodes all over the world. So on this blockchain itself, there is going to be things like smart contracts, and there are going to be things like accounts. So and it is very complex. And what do I mean by complex? So if we try to draw out the entire workflow and the state transition of a smart contract, it could start off with this. So let's say I'm account X. I could make a transaction to a smart contract C. And the smart contract C could call multiple transactions to contract D, could send out some tokens to account Y, can evoke another smart contract called contract E. And this can go on for a certain amount of depth because and also like, and sometimes like, let's say if you call contract E, the contract E can also re-enter contract C again. So this means that when you want to actually make sure that you don't you program correctly, you also must draw a similar state transition graph because there are some history where the one on the top right, that's actually a real security flaw that happened in 2017. Interacting with blockchain using wallets. So if we go back to here, like going back before, I mean that presentation on Casping was great because you have authentication part. But for blockchain, how do you authenticate? So that is being sent directly when you have a presence of a private key. When a private key is just a bunch of hexadecimal string over there. And what it generates is that it generates a public key, which will allow you to be able to verify your identity on the blockchain. And the private key also helps you to sign transactions. So let's say I want to send Michael some amount of like Bitcoin or Ethereum. Then I will need to sign a transaction with my private key, point it to Michael's address, and that's how a transaction happens. So going into this is that if we have an application, usually this web application usually interact with a blockchain through a RPC. So it's not like a magical thing where you have to run a blockchain network or node on your computer. So you could point it to some hosted services. This slide is on Zilliqa, which has its own ways. But on Ethereum, there are services like Infura that can provide you with these hosted services and an interface that you can call easily. So this is how you can actually build a web application. So going into Ethereum use case, right? So let's say if you have a client application, a front-end dashboard, what you would do to connect to the Web3 is that you can choose to install like a MetaMask. You can choose to ask your users to install a MetaMask extension. So this is like a Chrome extension that is on your browser. You can stick in your private key, and you can actually use that to actually interact with Web3 familiar applications. So recently on Forbes, right, you can actually pay using Ethereum. So if you want to pay for a subscription of Forbes.com, and you have this MetaMask extension enabled, you can actually authorize the payment. So all these things does not require you to put in your credit card number. It's very fast free, and it is not just powerful for just sending Ethereum or paying for microtransactions. When I say microtransaction, it is also useful for providing identity. So yeah, I think that once this actually takes off, like microtransactions can be a thing, because on the internet world, right, credit card transactions are very expensive. Not sure if anyone here is from Stripe, but Stripe earns a lot of money just by processing credit card transactions. So we hope that will go away someday, where transactions can be in the fraction of a cent, and that's how Zilliqa transactions are. Everything costs less than a cent, so you don't have to pay for this like hefty credit card bills. Okay, so and all these things will actually interact with like you can choose to interact with a local testnet for development. That will allow you to test your application and making sure that it's production ready. And once they're ready, you can push it to the main Ethereum network. And this can be either you host your own node, which is a gateway to this network, or you could use a hosted service like Infura. So this is like maybe like a more illustrative like kind of like thing with a more advanced concept called IPFS. So let's imagine that I'm trying to build a Twitter application on the decentralized application. So this is how I'm going to build it. I will use my standard React.js application as a web front end. I'll collect certain things like the tweet that you want to make as a string. I will allow you to upload a picture. So once that is done, right, I will actually send it to the IPFS, which stands for Interplanetary File System. It is a decentralized file system that allows you to host like image. Think of it like S3 bucket, but on the decentralized web. So Amazon S3 bucket, so like a Dropbox. So when you put your files there, they will return you a hash, and you can put a hash on the Ethereum blockchain to show that okay, this is the content that I have, and this is the sort of like URL, or I call it IPFS URL to that image there. Because the whole idea of blockchain is that it's decentralized. So let's say if you put it on AWS or you put it on Google, one day they may take it down, or one day you may get censored or blocked by a domain. But if you put it on the blockchain and the IPFS, it's censorship free. This will return a result. Once you put it into Ethereum, you get an Ethereum hash, and that's where you can display to your user that yes, I received a tweet and a picture. This is the hash that is being on the Ethereum blockchain. Whenever people wants to say interact with your content, so let's say that maybe your tweet has a donate button. What you could do is that you may have a Node.js server, and this Node.js server could also receive events from the Ethereum blockchain, just like a socket connection. So this is where you can actually receive things like a push notification through, and also push it back to your front end. So some things are good for the blockchain, but always remember that blockchain is not suitable for storing everything. So some things still must store in the standard MongoDB. So I usually like to tell people that blockchain is an extremely expensive database. It is not ideal for storing big data or doing all kinds of like saying large transactions. I mean, it's cool that people put like banana trails and audit trail on the blockchain, but you should try not to do so much of it because it can get pretty expensive. So yeah, so this is the overall view of how I will build a web front end. And I think maybe I just want to just go very briefly into some of the security attacks, because I think security is one of the most important topics to cover in smart contract programming. The key question here is that are we safe in this like smart contract space? So in the past few years, we have seen quite a lot of things like the DAO attack, which happened in 2016. That's where a re-entrancy attack. So going back to the complicated graph, like someone sends to a contract, the contract sends to another place and it re-enters a contract. That's a DAO attack, which I have an illustration for that later on. There's a parity bug where someone accidentally frees a multi-signature contract. And so far we have been good at, I think that I should have updated this slide with a 2020 because recently there was another smart contract that got exploited and multi-million-dollar is being lost. So it can get quite sophisticated over time, and I think that this will always go on. So this is like based on a research paper published by NUS. It says that out of all the smart contracts out there, there are quite a significant number of contracts that are vulnerable. So there are plenty of things. If you're coming from the angle of cybersecurity, there's lots of things to do on the smart contract portion. So going to this, like this is exactly what happened in the DAO attack and how things may go wrong. So let's say that I have a fundraising contract, and it means that I just want to get the amount of funds from the contributors, from the contributor, and I say that okay, if and I'm going to reset that to 0. I'm going to send some money from the sender to an account, and you call another, you try to send a transaction to a person. So usually this means that I will be sending money to a person. But in this case, right, what happens is that someone actually, instead of like, because this function, this code actually works if that recipient is a user. But this code does not work so well when the user is not when the recipient is not a user account, but it is a smart contract. So in this case, what happened in 2016 was that someone discovered this exploit, and they wrote another smart contract to basically point it back to here. So as you can tell, like from the last line, right, that's where the contributors get to 0. So that's where you reset the balance back to 0, because because whenever someone calls this, and you just enter a loop all along, and the contributor's amount never gets to 0, and that's where the attacker is able to drain the funds from the smart contract in real time. So the DAO is like you think of it then like a decentralized like venture capitalist. So people actually put money there, and they could actually invest in other projects. But because of this bug, you can see that the Ethereum and Ether is being taken away in real time, and it's like watching a bank robbery in real time, and you can't do anything about it. So this is something that's pretty interesting. Also, just to share very briefly on a few other exploits, is that what we call transaction ordering dependence, and this means that if we have two functions, update price and buy, the sequence of which goes first changes depending on which transactions get ordered on top, because it's a decentralized network, so you can't control which order it goes in. You can only control how much gas you want to put in. So there are ways that you have to make sure some transactions are before other transactions. So finally, the last thing is that because transactions and computations are expensive on the blockchain, so you need to be very careful about your resource consumption. So what happens if you do not actually do that? So let's say that I have an array that just keeps expanding over time, and I say that okay, whenever I try to empty an array, and then so whenever I want to win this lottery, I need to empty this array. But it may just be that whenever I want to empty this array, this may cost too much gas, and it may be beyond the gas limit of a certain block. So this might not be able to happen. So same thing as you're programming on the smart contract, you have to be aware of the limitations of a blockchain network, and how you master concepts like gas and transaction dependency. So I guess that's it. So there are just lots of things to cover, but I just want to share with you some of these more interesting things that will hopefully ignite your interest into blockchain programming, and feel free to ask me any questions. Thank you.
And no, it's okay lah, don't need lah. Yeah, so you want to close or? So we've come to the end of the meetup. Really appreciate all your coming for this, and it's a small, cozy little one. So yeah, I kind of like it. The videos will be online eventually. So eventually, you'll appear on the internet. Or actually, they're still live streaming right now, so might be still up. Anyway, there's still food, right? So if you are still hungry.
Is there a lot of food? Quite a lot.
I can't remember.
Okay, so my ask is, can everyone just take a box back? Can anyone else take as in Tupperware
Eat some, take it back for your friends.
Family.
Family.
Honestly, it's not good to waste, so it's nice to take it home.
Right.
Yeah, free food, man.
Anyway, so let's take a quick. Woohoo! Hey,
Thank you,
internet.
everyone. You still like
Alright, so yeah.
How many people did we have on live stream?
Uh,
Do we know?
10-ish.
10-ish people. 10.
Pretty not bad.
Okay, cool. Anyway, it's Friday. It's Friday. Go again. Enjoy your Friday night. And Thank you all for spending time with us on the Friday night. Cool. Bye.